Welcome to RiverRoot Aquatic Engineering. In the world of aquaria, there is a common frustration. Why do even the most expensive setups sometimes fail to achieve that polished water? The answer lies in shifting our perspective. A filtration system is not just a cleaner, it is a complex, coupled system of fluid mechanics and microbial ecology. Today, RiverRoot will take you beyond the hobbyist level into the engineering principles of the aquatic blueprint. Rigorous filtration is built on three pillars. Mechanical filtration is your front line, intercepting suspended solids before they can rot in the biozone. Biological filtration is the heart, providing the surface area for nitrifying bacteria to thrive. Finally, chemical filtration acts as a tactical utility for removing medications or tannins. Ignoring physical interception effectively turns your biofilter into a septic tank, a critical error in system design. At RiverRoot, we quantify system health using the nitrification capacity formula. It is a function of ESSA, effective specific surface area, DO, dissolved oxygen, and T, contact time. Even the best media is useless if the water flow doesn't carry enough oxygen, DO, or if the flow velocity is so high that contact time, T, is insufficient for the bacteria to process ammonia. Balancing these variables is the secret to a stable nitrogen cycle. Media efficiency is often lower than advertised due to bypass flow. Water is lazy. It follows the path of least resistance. If a filter is poorly designed, water flows around the media rather than through it, reducing actual surface area utilization to less than 30%. Engineering a successful system means ensuring uniform flow distribution across the entire cross-section of your media. The top filter is a classic for a reason: oxygen. Its engineering brilliance lies in the waterfall return, which dramatically expands the gas-liquid interface, keeping dissolved oxygen, DO, near saturation levels, typically 7.5 to 8.5 milligrams L. While it is unmatched in cost efficiency and maintenance ease, it is limited by media volume and CO2 loss, making it unsuitable for high-end aquascaping. For the aquascaper, the canister filter is the standard. Its sealed, pressurized design eliminates bypass flow and prevents CO2 from escaping. It is also the quietest option, often operating below 25 decibels. However, being a closed system, its oxygenation is limited. RiverRoot advises that for high-load fish tanks, a canister filter alone may face oxygen bottlenecks during high temperatures. If efficiency is your goal, trickle filtration is the engineering limit. By surrounding the water with air rather than submerging the media, it creates a thin film interface. This allows oxygen to diffuse into the biofilm with zero resistance, making its nitrification rate 3 to 8 times higher than submerged systems. It is the industrial solution for high-density monster tanks and koi ponds. A sump elevates filtration to an independent subsystem. It often increases total water volume by 30 to 50%, providing massive thermal inertia and chemical stability. It allows for the perfect concealment of heaters, UV sterilizers, and protein skimmers, leaving the main display visually pristine. It is the gold standard for marine reefs and large-scale displays. There's no best filter, only the right tool for the scenario. RiverRoot recommends top filters for high-oxygen, low-budget setups, canisters for quiet, CO2-dependent aquascapes, and sumps or drip towers for high-load systems over 150 centimeters. Choosing a system that is under-engineered for your bioload is the leading cause of old tank syndrome and ammonia spikes. ODA matters. RiverRoot advocates the sandwich strategy. First, the physical interceptor, fine and coarse wool. Second, high-SSA biological media, ceramic rings or nanospheres. And finally, functional media like activated carbon or peat. Reversing this order allows debris to clog your biomedia, suffocating the nitrifying colony and causing system collapse. Don't be fooled by pump labels. Manufacturers often quote head pressure, zero flow rates. Once you factor in pipe friction, gravity, head height, and media clogging, your actual flow is often half of the rated capacity. For a high-load 100L tank, You don't need a 500LH pump, you need a pump rated at 1000H to ensure a real-world 5x turnover. Is your filter keeping you awake? 70% of noise comes from pump vibration. By isolating the pump with a 2 cm high-density sponge, you decouple the vibration from the glass and cabinet, turning a hum into near silence. Additionally, using underwater returns with 45-degree cuts eliminates splashing noise while maintaining water circulation. A power outage is a life support crisis. Without circulation, oxygen is depleted rapidly and the biofilm begins to die within 6 hours. The RiverRoot protocol. Have a battery-powered aerator. Stop feeding 24 hours before a planned outage. And use sponge filters as a backup, as they provide both aeration and basic bio-support during emergencies. We are moving from mechanical to digital management. High-end systems now integrate pH, ORP, and TDS sensors for real-time monitoring. However, as we explore low-tech Wallstad methods or smart IoT setups, remember the fundamentals. Sensors only report the crash, the engineering of your flow and media prevents it. The essence of an aquatic blueprint is not buying the most expensive media, but building a balanced, stable micro-world. We hope this engineering perspective helps you master your water. This is RiverRoot, the rational side of the aquarium world. Follow us for more deep dives, give us that one-click triple action support, and leave your tank specs in the comments. We'll do our best to provide custom engineering advice. See you in the next blueprint.